So today we will discuss about addressing modes. Addressing mode is the way or the method how we are accessing our data. So basically there are many categories of the addressing modes. For example, there is immediate addressing mode, another form is register addressing mode, another form is direct addressing mode, fourth one is register indirect addressing mode, and fifth is indexed addressing mode. So these are the 5 classes of addressing modes. So the addressing mode is the mechanism or the way or method by which we address or we access our operand. So first we will discuss about immediate addressing mode. So in case of immediate addressing mode, the operand is the part of the opcode. For example, move. We will discuss these addressing mode with the help of move instruction. Move instruction is basically used for the transfer of the data. So already we discussed in previous lecture about the move instruction, but again I repeat, with the move instruction there are 2 parts. One is destination, comma, source. So here the data from the source will be moved to destination. Data from the source will be moved to destination. Now, depending upon our source, what type of source we are having, whether our data is a immediate data or the data is in register, or we are mentioning the address of our data. So depending upon the source, the addressing mode will be defined. So now here we will take the example of immediate addressing mode. So first case, move. Suppose here for the destination we take one register Rn, comma, hash, data. Here for Rn, in Rn, n is equal to 0 to 7. Means R0, R1, R2, R7. So here Rn indicates the bank registers R0 to R7. So here we want to transfer our data from source to destination, and the data is just here we are mentioning the data, and before the data we have just added a symbol hash. So this indicates This is an immediate data. This is an example of immediate addressing mode. So for example, move R0, comma, hash 34H. So here this is our opcode and this is our operand. So with the opcode, operand is the part of the opcode with immediate data. So this is the example of immediate addressing mode. Only thing you have to just take care, the size of register should match the size of your data. Here this register, we know it is a 8-bit register. So in a 8-bit register you can store only 8-bit number. You cannot use this instruction move R0, comma, hash 3439H. So this is a 16-bit data. So this will give you error because here you are trying to load a 16-bit number in a 8-bit register. So the size of our source and destination must match. So this is case 1 and case 2 of immediate addressing mode is move, and here for the destination in place of register we can use here address, direct address, comma, hash data. Now for example, move 30H, comma, hash 40H. So here this is our source and this is our destination. Now in the source we have used the symbol hash. So this symbol indicates that this is a data, and in the destination there is no hash symbol. This indicates that this is an address. So here we want to transfer an 8-bit number which is 40H into an internal RAM whose address is 30H. So in this case 40H will be loaded at internal RAM whose address is 30H. So just by saying our source, so again the source is immediate value, immediate number. That's why this is an example of immediate addressing mode. Now case 3, move @RI, comma, hash data. Now here in RI, I is equal to 0 or 1. So if we are using @ symbol before this RI, then we can use only 2 registers of the bank, and that is R0 and R1. Only these 2 registers can be used with @RI. Means we can use @R0 or @R1. We cannot use @R2, @R3 or @R7. So those are invalid. Now what is the meaning of this destination? Here the content of this register points the memory address. For example, I will take one example. Let us assume let us assume the value of R0 register is 20H. 20H is the part of R0 register. And we have written this instruction, move at the rate R0, comma, hash 30H. Now, this is our source, which is the immediate data. This data will be moved in internal memory, in internal RAM, and the address is defined by or pointed by R0 register. The value of R0 is 20H. So this 30H will be moved at address 20H. So here we will take this example. This is our RAM. This is our RAM. Now, in this instruction, what will happen? In R0 we are having 20H, and move at the rate R0, comma, hash 30H. So the value of R0 will point the RAM location. We know that in the RAM we are having the addresses from 00H to 7FH. Now, in between these addresses, R0 points the memory address 20H. So here we will have some RAM address 20H. So now this 30H value, this is, see, before 30H we have just placed hash. This indicates this is the data now. This 30H will be moved at address 20H. So here we will find now 30H will be stored at this address. Whereas in case 2, directly we have mentioned the address, move 30H, comma, hash 40H. So here this 40H will be moved at address 30H. So in this memory, from the addresses 00H to 7FH, there is some address 30H address is also there. So at the 30H, this data 40H will be moved. So here at the 30H we will find 40H. So the difference here is between case 2 and case 3, the destination address is directly given in this instruction, whereas in case 3 the destination address is stored in R0, and with the symbol at the rate R0 we are pointing that particular memory location. And in the case 1, directly we are loading the data in R0 to R7. And here, of course, in this instruction you can use R0 to R7, as well as you can use a register A and register B also. Both the registers can also be used. For example, for this, move A, comma, hash 20H. So in this case, this 20H value, 8-bit value will be loaded in A register. Or in place of A, you can use B also. So in that case, move B, comma, hash 20H. So 20H value will be loaded in register B. Okay. So here for you just keep in mind that whenever you are using this at the rate Ri, so here you can use only two registers, that is R0 and R1 only. You cannot use R2, R3, R4, R5, R6 or R7. So this is the example of immediate addressing mode. Then we will come to next one. Direct addressing mode. You just give this mark, right? This one. Now, direct addressing mode. Case 1, move direct address, comma, direct address. For example, move 20h, comma, 30h. So this is the example of direct addressing mode. How you will identify a particular instruction belongs to which addressing mode? You just check the source. So this is our source and this is our destination. So source is an address. Direct address is mentioned with the instruction. So this is an address. So what this instruction will do? The 8-bit data which is stored at address 30h, that will be moved to address 20h. So here suppose this is our RAM. In RAM we are having this address 30h and we are having this address 20h. Addresses will start from 00h to 7fh. So at 30h, suppose we are having some data, let us assume it is A3h. So now when this instruction is executed, then the content is stored at this address. See here we are not having this symbol. If you put this symbol, then this will become data. Now this symbol is, hash symbol is not there, this indicates now this is an address. At this address, whatever data is there, right now it is A3, it will be moved to address 20h. So now this A3 will be moved to address 20h. So here A3h will be stored. So this is case 1. In case 2, move some register, comma, direct address. For example, now this register can be Rn, A or B. Rn means R0 to R7, or you can use the destination register A, or you can use register B. Right? So the example is move R0, comma 30h. So here what will happen? The content which is stored at address 30h, it will be moved in R0 register. Now R0 can be the part of bank 0, bank 1, bank 2 or bank 3, and we know that by default this R0 belongs to bank 0. And so in this case, now suppose this is your RAM. In the RAM at this address 30h, we are having some data A3h, and this is your address 00h, 01h, like this 7fh, and this is your R0, this is your R1, like this. So the content stored at 30h will be stored in R0. So at 30h we are having A3. So now A3 will be moved to R0. So here you will get A3h. So same type of instruction is there in immediate addressing mode. In this way, move R0, comma hash 30h. So now you can find out the difference between this instruction and this instruction. In this instruction, 30h will be loaded in R0. 30h will be the part will be stored in R0. But in this instruction, the content stored at 30h will be moved in R0. So generally, students they just do this mistake. You just understand the difference between with this hash symbol and without the hash symbol. Without hash symbol, it is now address. With the hash symbol, it is now data. Now, case 3, move at the rate RI, comma, direct address. So now in this case example, move at the rate R0, comma, 30H. So in this case, the content stored at address 30H will be moved in internal RAM. And what is the address of internal RAM? Where it will be stored? That will be pointed by R0. So let us assume in R0 we have 7FH. In R0 we have 7FH. So now what this instruction will do? Let us assume this is our RAM. This is address 00H. This is 7FH, and somewhere it is 30H. At 30H we are having content 02H. This is the data which is stored at 30H. So now let us assume R0 is having value 7F. Now move at the rate R0. So now the content of R0 will become the address. So data from 30H, from this address. At this address we are having this data. This data will be moved in internal RAM at address 7FH. So 7FH is this address. So here at this address, this data 2002H will be moved. Then third addressing mode is register addressing mode. So here the destination, the data is in the data which is in destination is stored in some register. In this case 1, move direct address, comma, RN or A or B. For example, move 30H, comma, R0. So now in this instruction what will happen? The content of R0, which is a 8-bit data, that will be stored in internal RAM at address 30H. Suppose let us assume this is the internal RAM, this address is 7FH, this is 30H, this is register R0, this is R1, like this. And in R0 register, so by this R0 is of bank 0. By default it is bank 0. Suppose in R0 we are having some value 23H. So when we write this instruction move 30H, comma, R0. So the content of R0, which is 23H, it will be moved in 30H address. Now here this is our source, and our source is a register. The data is in register, operand is in register. That's why it is a part of register addressing mode. So here we can use R0 to R7, any register can be used. We can also use A register or we can also B register. For example, move 30H, comma, B. So here the content of register B will be stored at internal RAM and whose address is 30H. At this address, content of B will be stored. Now, can we use this move Rn, comma, example, move R0, comma R7. So this is invalid. This the movement of the data in between R0 and R7 directly by including these names is not possible. So this type of instruction is invalid. We should not use this instruction. R0, Rn to Rn data movement is not possible. But of course, in place of this, you can use register A. So from register A, you can move the data in R0 register, or R2, comma B. From register B, you can move the data in R2 register. So basically, Rn, that is between R0 to R7, any of the registers, you cannot use as a source and destination in one instruction. And this is also not possible. Move at the rate Ri, comma R. So this instruction is also invalid. For example, move at the rate R0, comma R2. So this is invalid. So if we are using the destination at the rate Ri, then we cannot use the registers, bank registers as a source. So this is invalid. But of course, in place of R2, you can use this move at the rate R0, comma A. A register is possible, or B register value can be transferred. This is possible. But this particular instruction, this is invalid. The fourth is register indirect addressing mode. Now in case of register indirect addressing mode, we will use at the rate Ri as a source. For example, we take case 1, move direct address, comma at the rate Ri. For example, move 30h, comma at the rate R0, or move 20h, comma at the rate R1. So here what we are going to do, so this is our source. So the data is stored in internal memory and the address is pointed by R0 because we have used the symbol at the rate. So at the rate indicates that whatever is the value of R0, that is the address of internal RAM. So the data stored at that address will be transferred to the address 30h. For example, suppose let us assume this is R0 register, this is 30h register, this is 7F address, this is the 30h address, and let us assume in R0 we are having 20h. The value of R0 is 20h. So now with this instruction, what it will do? It will load the content which is stored at the address pointed by R0. R0 is having 20h. So at the address 20h, whatever value is there, suppose here we are having FF. So FF will be moved to address 30h. So now here we are having FFH. This will be moved. And in case of register indirect addressing mode, the invalid instructions are this: move at the rate RI, comma, @RI. So this is your invalid. You cannot use. At the source and destination, at the both place, we cannot use indirect addressing mode symbol. For example, move @R0, comma, @R1. So this is not possible. This is invalid instruction. And another invalid instruction is move RN, comma, @RI. So this is also invalid. So in case of register indirect addressing mode, we cannot directly move the data in RN register. For example, move R7, comma, @R0. This is not possible because directly we cannot move in R7 register. So this is also invalid, this is also invalid. But of course, here you can use A or B register. That is valid. Move A, comma, @R0. This is possible. So here the destination is A register. In A register we are loading the content of the internal RAM, and the address of that content is pointed by R0 register. So this is possible. So A and B register can be used, but directly RN register cannot be used. So this is about register indirect addressing mode. Now index addressing mode is also there, that is the fifth one. So first we will just see few examples based on these four addressing modes in the next lecture. Then we will discuss about the index addressing mode after that.